So let us learn midpoint theorem. So midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. What is the meaning of it? By drawing a figure, we can understand that we have a triangle here. Okay, in this triangle, let us say this is a midpoint here of this side, this is the midpoint of this side. And when we draw this line, when we join this line, so this line is parallel to this third side, and this line length is equals to half of this. So suppose if this is 4, this is 8. Understood? So this is double of this, or this smaller line is half of it. This is what you have to prove here, and this is what the midpoint theorem says. Okay, so let's start with a proper figure over here. Whenever a theorem is being asked, you need to draw a figure first. And we have the two midpoints here. Let's say name them D and E respectively and join this line. So first step in proving a theorem is always to write given. So what is given to us is that we have a triangle. So in triangle ABC, what all is given in this triangle? In triangle ABC, D and E are the midpoints of AB and AC respectively. The meaning of respectively here is that D is the midpoint of AB and E is the midpoint of this AC. Okay, now you just write that join DE. What do you have to prove over here? We have to prove that DE is parallel to BC and DE is equals to half of BC. This is we need to prove. So how are we going to prove it? We need to do some construction step over here. Otherwise, there is no way to prove it. Okay. So what construction we will do is we will produce this line DE. We will produce this line DE to a point F and then join that point with C. Let's say this is that point F. Okay. We are produced in such a way that this CF is parallel to BA. Okay. So we have to do a construction first. Let us write the construction. Let's produce DE to F, join CF such that CF is parallel to BA. Clear till here step? We have written given, we have written to prove, and we have written construction. Now we have to do the proof. This is the part of the theorem where you will prove. So let us take this figure, or we have to draw this figure or come back to this figure again and again. Okay. So now the first step over here I'll just tell you is first what we will do is we will prove these two triangles, this triangle AED and triangle CEF congruent. How can we prove them congruent? We can say that AE is equals to EC because E is the midpoint of AC. Okay, we have this angle AED equals to angle CEF, vertically opposite angles, and we also have this angle DAE equals to FCE, alternate interior angles, because the lines BA CF they are parallel, so these are alternate interior angles. So I have angle side angle condition over here, the congruence rule. So let's begin with in triangle AED and triangle CEF. What we have first thing, I'll write angle AED equals to angle CEF, vertically opposite angle. AE equals to EC, I'll write AE equals to CE. This is why, because E is the midpoint of AC. Then I have angle DAE equals to angle FCE. This is what? Alternate interior angles. Okay, so By what rule the triangles are congruent? By ASA, triangle AED is congruent to triangle CEF. I hope this much is clear. I'll just draw the figure again over here for a quick reference. A, B, C, D and E are the midpoints. Reduce it to F and you join it. This is F. So I have proved triangle AED congruent to triangle CEF because AE equals to CE. This angle vertically opposite, this angle equals to this angle, alternate interior. So by angle, side, angle, the triangles are congruent. Now when the triangles are congruent, what do I have from here? What I got is that AD equals to this, AD equals to CF. I have one thing over here. And I also have DE, this ED and EF. Yeah, DE equals to FE or EF. Okay, these both things are by CPCT. You know what's the meaning of CPCT? That is corresponding parts of congruence triangles. Okay, now I also have that this BD is parallel to CF. This is by construction. By construction, we said that BA is parallel to CF. So when BA parallel, I can say BD is also parallel to CF. Okay, okay. So can I say that BD also equals to CF? Yes, BD also equals to CF. Why? Because AD equals to CF and AD also equals to BD, as D is the midpoint of AB. So this AD, AB, they both are equal to each other. And as AD come out to be equals to CF, so DB and CF, they both are equal to each other. Now this BD is equal to CF and this BD is parallel to CF. So let's say this is 1, this is 2. So from 1 and 2, I will say that this BCFD is a parallelogram. Opposite sides are, one pair of opposite side is parallel and equal. So that's a parallelogram. So what does this show? This implies if this is parallel, this is equal, it's a parallelogram. So can I say that DF is also parallel to BC and DF is equals to BC? I got one part. DF is parallel to BC. DF is parallel. So can I say the part of this line DE is also? So therefore DE is parallel to BC? Yes, that's a part of the line. Now DF is what? DE plus EF is BC. DE and EF, they both are equal over here. Fine. So DE plus DE equals to BC. This is from I can say CPCT. Yes. So 2DE equals to BC. So what do you get? DE equals to half of BC and you have DE is parallel to BC. Hence, prove. This is what we have to prove. What was there to be proved? That DE parallel to BC, DE is half of BC. Okay, students, I hope this is clear. We did only two steps. First step, we proved the two triangles congruent after construction, okay, by ASA. Then we make that this parallelogram is there, BDFC is a parallelogram. Now when it becomes a parallelogram, its opposite sides are equal and parallel and you are done with the proof. Okay, so practice the theorem. You need to solve it many times to understand it. Okay.